So I've been asked a couple of times about one of these questions because it involves heat energy and mole calculations. So in an experiment we've got 0.75 grams of benzene, which is C6H6, and it's completely burned in air. The heat evolved raised the temperature of 200 grams of water by 43.7 degrees. Use this data too, and then we've got 4 separate calculations that we need to do. Part A asks us to calculate the heat given off by the 0.75 grams of benzene. So I've scribbled the answer on here, but just follow through with me. Q, the energy, is the mass of the thing that's been heated up, in this case it's water, times by the specific heat capacity. Now you'd always be given this, but I've told you here it's 4.2 for water, times the change in temperature. So here, instead of having a start and a final temperature, you've got the change, which is 43.7 degrees Celsius. So to calculate that, Q is 200, we got that from the mass of the water, times by the specific capacity of water, 4.2, multiplied by the change in temperature, and if you put those numbers in, you get 36,708 joules, or we'll call that 36.7 kilojoules. So part B, calculate the heat given off by benzene in kilojoules per gram. Right, so the hint is you've got the units here, kilojoules per gram, so it's kilojoules divided by grams. So the formula is going to be the number of kilojoules divided by the number of grams. So it's 36.7, because that's the number of kilojoules we calculated, divided by the mass in grams, which we've got up here, 0.750, and if you calculate that, it comes out as 48.9 kilojoules per gram. Now most people manage to get part A and B quite well. Part C is where it gets a bit more confusing. Calculate the moles of benzene burned. So we'll just jump out of that question and work that out separately. So to find the number of moles of benzene in 0.75 grams. So I'll put this triangle up, hopefully you've seen this before, this is one taken from the lessons I teach. So the first thing we've got to do is find out the MR. So MR is the molecular mass, or AR the atomic mass. So that's an atom and that's a molecule. So the MR of benzene, we've got to add up the relative atomic masses for each atom inside benzene, which is why they've given you this molecular formula. So there are 6 carbons, so that's 6 times 12. Now 12 is the relative atomic mass of carbon off the periodic table, and there are 6 hydrogens, that's 6 times 1, and that's the relative atomic mass of hydrogen off the periodic table, which gives us 6. So 72 and 6, the total mass of a benzene is 78. Now we can put these numbers in to our triangle. So the mass we were given at the start, the mass in grams is 0.75. The MR we've just calculated as 78. So the number of moles is going to be the mass in grams over there divided by the MR, which is 78, which will give us 0.00962 moles. So that's the difficult bit worked out now. We've got the answer of 0.00962 moles of benzene that was burned. So part D is now going to ask us to calculate the heat given off by benzene in kilojoules per mole. So once again we've been given these units, so that's a big clue. So the units are kilojoules divided by moles. So that means we just divide the number of kilojoules that we calculated right at the beginning, 36.7, and instead of dividing by mass, as we did in part B, we're going to divide it by the number of moles. So it's going to be 36.7 divided by this 0.00962, which gives us an answer of 3,820 kilojoules per mole.